Something arrived in our solar system. It was not from here. It did not belong here. And the most advanced telescopes ever built by human civilization, the James Webb Space Telescope and the Vera Rubin Observatory, both locked onto it, studied it, and came back with answers that nobody in mainstream science is fully prepared to explain. This object is older than our sun. It carries chemistry that does not exist anywhere in our solar system. And the deeper scientists dig into its data, the more one terrifying realization keeps surfacing. We are not looking at a comet. We are looking at a message. There's a moment in science when everything a civilization assumed about its place in the universe quietly collapses. Not with a bang, not with a press conference, not with the president walking to a podium. It happens in the cold silence of a data file. It happens when a scientist stares at a number on a screen and realizes, with absolute certainty, that the number should not exist. That is the moment we are living in right now, and almost nobody is talking about it with the weight it deserves. In the summer of 2025, something entered our solar system from the direction of the stars. It was not a planet. It was not a spacecraft. At least, not in any conventional sense. It was a comet. But calling it a comet, the way you might call any other comet, a comet is like calling a nuclear weapon a piece of metal. The label is technically accurate and completely, dangerously misleading. This object, designated 3I Atlas, was the third interstellar visitor ever confirmed in recorded human history. Only 3 objects from beyond our solar system have ever been caught passing through it. The first was 1I, Oumuamua, the second was 2I, Borisov, and the third is 3I Atlas, which is turning out to be something stranger still. Think about what that number means. In all of human civilization, with all of our telescopes, all of our mathematics, all of our centuries of stargazing, we have only ever confirmed 3 objects that crossed the boundary of another star system and entered ours. 3. And this one, the third one, is the most unsettling of them all. But here is where the story truly begins. Because finding 3I Atlas was only the first act. The second act is what happened when the world's most powerful observatories started pointing their instruments at it, and the data that came back began rewriting the textbooks in real time. The Vera C. Rubin Observatory sits at an elevation of 8,170 feet on a mountaintop in Chile's Andes Range, named after the American astronomer who discovered one of the key pieces of evidence for the existence of dark matter. It began observing the heavens in 2025. It was still in its commissioning phase, still being calibrated, still being tuned, still learning to breathe, when 3I Atlas entered the solar system. And yet, even in this raw, unfinished state, Rubin caught the visitor. Interstellar comet 3I Atlas was almost called 3I Rubin after researchers found that the giant survey telescope coincidentally spotted this visitor from the stars over a week before it was officially discovered. Let that settle into you for a moment. A telescope that was not even fully operational yet, a telescope that was still being assembled in the metaphorical sense, managed to capture humanity's most extraordinary cosmic visitor before any other instrument on Earth realized it was there. Had the science validation survey started sooner and had the analysis pipelines been operational, Rubin might have been the first to welcome humanity's third interstellar visitor. This was not a failure. This was a preview of what Rubin is going to unleash on our understanding of the universe. Because Rubin did not just take a photograph of 3I Atlas. Rubin's team successfully made astrometric measurements, collected photometry, determined 3I Atlas's orbit, and studied the comet's structure and nucleus. Among other findings, the data clearly showed the presence of the object's fuzzy coma, providing the earliest high-resolution evidence of cometary activity. In other words, before anyone had officially named this thing, before anyone had confirmed it was real, Rubin had already mapped its trajectory, measured its glow, and recorded the first evidence that it was alive, churning out gas and ice as it plunged toward our sun. This was not luck. This is what Rubin was built for. And the fact that it captured 3I Atlas almost by accident, during a period when it was not even officially online yet, tells you something profound about what is going to happen when Rubin begins its full-scale survey of the sky. With the Rubin Observatory now scanning the sky, many more interstellar objects may soon be found. We have been alone in this cosmic neighborhood for all of recorded history. That chapter is ending. But what Rubin started, the James Webb Space Telescope finished, and the findings that came out of Webb's analysis of 3I Atlas are, without exaggeration, some of the most consequential scientific results of the 21st century. After 3I Atlas made its closest approach to the Sun on October 29, 2025, and survived intact, because yes, there was genuine uncertainty about whether it would survive at all, astronomers saw their window. As interstellar comet 3I's Atlas began moving away from the Sun in December 2025, astronomers took the opportunity to turn the powerful James Webb Space Telescope in its direction and capture detailed measurements of its chemical components. The comet was freshly warmed from its closest pass by the Sun, and its ancient ice had been converted to a bright coma of gas, ideal for observation. This is the scientific equivalent of cracking. Open a sealed vault from another civilization. The heat of our Sun had done what no human instrument could. It had melted open the object's surface and released billions of years of preserved chemistry into a glowing cloud around its nucleus. And Webb, with its unmatched infrared sensitivity, read every molecule in that cloud like a barcode from another star system. What came back from those measurements was not what anyone expected. Webb captured detailed data, including chemical ratios of carbon and deuterium, also known as heavy hydrogen, that are not found in solar system comets. The results surprised researchers. I read that again. The results surprised researchers. These are scientists who spend their careers studying the most exotic objects in the known universe. These are people who have cataloged the chemistry of hundreds of comets, who have modeled the interiors of gas giants, who have watched supernovae collapse in real time, and the data from 3I Atlas surprised them. That is not a minor footnote. That is the headline that the world is not treating with the seriousness it deserves. Here is what the data actually showed, and why it matters far more than the press releases suggest. The deuterium to hydrogen ratio in 3I Atlas is completely unlike objects in our solar system and objects found far beyond it. The ratio is so unusual that even the lead researcher on the Webb study said, "What we're seeing here is an object that doesn't seem to match our own solar system, our own comets. It doesn't match nearby protostars either. So this is something new and different." Something new and different. In science, that phrase is a seismic event. Scientists spend entire careers confirming what is already known. When a researcher looks at data from the most powerful space telescope in human history and says, "It does not match anything in our catalog," that is not a casual remark. That is an admission that we have encountered something outside the boundaries of our current model of how the universe works. The deuterium to hydrogen ratio for 3I Atlas is more than 30 times higher than that of solar system comets, suggesting that it formed in an environment significantly different from our own, 30 times higher. To understand why that is staggering, you need to understand what deuterium is and what it tells us. Deuterium, or heavy hydrogen, is an isotope that forms under very specific conditions. Extreme cold, extreme age, and very limited presence of heavier elements like iron, carbon, and oxygen in the environment. The more deuterium an object contains, relative to regular hydrogen, the colder, older, and more chemically primitive the environment it formed in must have been. And 3I Atlas contains so much deuterium that the only environment that could logically explain it is one that existed at the very edge of time, in the cold, metal-poor outer regions of a star system far older than our own. The unusual isotopic ratios indicate that 3I Atlas probably formed in the outer regions, around an old low metallicity star, a star with mostly hydrogen and helium and very few other heavier elements. What astronomers are calling low metallicity is, in simpler terms, a star that formed before the universe had been enriched by generations of supernovae. Every heavy element that exists, the iron in your blood, the calcium in your bones, the silicon in the computer chip running the device you are watching this on, was forged inside a dying star and scattered into space when it exploded. The first stars that ever existed had none of that. They were made entirely of the primordial hydrogen and helium left over from the Big Bang. And 3I Atlas bears the chemical signature of a world that formed around one of those ancient primordial suns. Researchers estimate that 3I Atlas may have formed 10 to 12 billion years ago. Our solar system is approximately 4.6 billion years old. That means this object predates our sun by 6 billion years or more. It was already ancient before our planet existed. It had been traveling through interstellar space longer than Earth has been alive. And it chose, if we can use that word even loosely, this particular moment in history, this particular window of time, to pass through our solar system at the exact moment when we had just deployed the first instruments capable of reading its chemistry, at the exact moment when Rubin was coming online to track it, and Webb was in orbit to analyze it. There is a word for that kind of timing, and that word is not coincidence. But the chemistry is only one part of what makes 3I Atlas so disturbing. The organic molecules inside it are equally extraordinary. Observations using the Atacama large millimeter, submillimeter array reveal that 3I Atlas carries an extraordinary amount of methanol relative to other molecules. The ratios measured place the comet among the most methanol-rich objects ever studied, including every comet that formed around our own sun. Methanol. That is an organic compound. It is built from carbon, hydrogen, and oxygen, It is one of the foundational stepping stones toward the chemistry of life, and this ancient interstellar visitor is saturated with it in concentrations that dwarf anything in our own solar system. The Atacama Array also identified the chemical fingerprints of hydrogen cyanide, a nitrogen-bearing compound commonly detected in solar system comets. And separately, a study using the European Southern Observatory's Very Large Telescope analyzed 3I Atlas's carbon and nitrogen varieties in the form of the chemical cyanide, with researchers noting, "For us as scientists, finding these rare isotopes is fascinating, but the bigger picture here is looking at the possibilities of prebiotic chemistry elsewhere in the galaxy. So far, we know of only one place in the vast cosmos where chemical ingredients led to life: our solar system, our Earth." Let those words echo for a moment. The researchers themselves are raising the question. They're not just saying that 3I Atlas is chemically unusual. They are explicitly pointing to its contents and asking whether the ingredients for life might exist somewhere else in the Milky Way. This object is not just a rock. It is a chemical library from a dead or dying star system that may have harbored conditions for life. And it just walked through our front door. Now here is what mainstream coverage is not connecting, and what informed sources close to the data understand that the general public does not yet fully grasp. James Webb and Vera Rubin did not just both look at 3I Atlas. They confirmed the same terrifying picture from two completely different angles. Rubin confirmed the object's existence before any other telescope even knew it was there. Rubin captured its early coma, tracked its orbit, measured its movement, and established that it was already active, already releasing its ancient contents, long before anyone was looking. And Webb then unlocked those contents with its infrared eyes, reading the chemical fingerprints of a universe 10 billion years older than our nearest star, and finding inside them the very building blocks that, on Earth, eventually gave rise to biology. Two telescopes, two different methodologies, one terrifying conclusion. This object is not like anything that has ever come from inside our solar system. It is not like anything that formed around nearby stars. It is a relic from a cosmic era we can barely comprehend, carrying chemistry that challenges our understanding of how life emerges. And it passed through our solar system at the precise historical moment when we finally had the tools to understand what we were looking at. The real story is this. What 3I Atlas has forced scientists to confront is not just the object itself. It is the implication of the object. The kind of chemistry that makes large amounts of deuterium requires two conditions. It must have been intensely cold wherever this icy rock formed, because reactions at those temperatures tend to make more heavy hydrogen. This means 3I Atlas spent billions of years in conditions so cold and so remote that it was effectively a time capsule sealed at near absolute zero temperatures, preserving its original chemistry across an incomprehensible span of time and distance. The universe did not just send us a visitor, it sent us a record, a sample, a specimen from an era of the cosmos that we otherwise have no direct access to. And now consider the dark matter layer of this story, because it connects directly to what both James Webb and Vera Rubin are revealing simultaneously on a separate but equally staggering front. In January 2026, using data from the James Webb Space Telescope, scientists produced one of the most detailed high-resolution maps of dark matter ever created. The image contains nearly 800,000 galaxies and shows how dark matter overlaps and intertwines with regular matter across cosmic scales. Dark matter, the invisible substance that makes up approximately 27% of the entire universe, has been theoretical for decades. We have known it exists because of its gravitational influence, but we have never been able to see it directly. And now Webb has mapped it with a precision that was previously impossible. Dense regions of dark matter are connected by lower density filaments, forming a web-like structure known as the cosmic web. This pattern appears more clearly in the Webb data than in earlier Hubble imagery. Ordinary matter, including galaxies, tends to trace the same underlying structure shaped by dark matter. Think about what that means. Every galaxy you have ever seen photographed, every spiral arm, every cluster, every collision of titanic stellar systems is not moving on its own terms. It is being guided, shaped, and structured by an invisible framework of dark matter that we are only now beginning to map in detail. The universe we thought we understood, the universe of stars and planets and light, is just the surface layer of a far deeper structure. And Vera Rubin, the woman whose observational work in the 1970s first provided hard evidence for dark matter's existence, now has an observatory bearing her name that is set to map that same invisible framework across the entire sky. The James Webb Space Telescope has revealed observations of young galaxies with unexpectedly elongated shapes that challenge established cosmological models. The current standard model of cosmology, the framework that explains how galaxies form, how dark matter clusters, how the cosmic web develops, is being stress-tested by Webb's observations in ways that were not anticipated. Galaxies in the early The universe are not behaving the way the models predicted. They are too large, too structured, too bright, appearing too early in cosmic history. And now, with the dark matter map providing additional resolution, scientists are realizing that the framework itself, the invisible scaffolding of the universe, may behave differently than the equations describe. What most people are not seeing is the convergence. Rubin and Webb are not simply two powerful telescopes operating in parallel on separate problems. They are two instruments that are simultaneously closing in on the same set of foundational mysteries from different directions. Rubin is mapping the wide, sweeping survey of the sky, cataloging asteroids, tracking interstellar visitors, eventually creating the most comprehensive three-dimensional map of the observable universe ever assembled. Webb is going deep, dissecting the chemistry of objects at the edge of the solar system, mapping the dark matter invisible to every previous instrument, studying galaxies as they existed just hundreds of millions of years after the Big Bang. Together, they are building a picture of reality that is more complete and more unsettling than anything that has come before. And 3I Atlas sits at the intersection of both investigations. It was caught by Rubin, it was decoded by Webb. And what it revealed, a chemistry unlike anything in our solar system, an age older than our sun by billions of years, isotopic ratios that match no known environment in the modern universe, points toward a cosmos that is stranger, older, and more inhabited with the ingredients of complexity than our current models account for. According to informed sources in the astronomical community, the publication of the Webb findings on 3I Atlas in Nature in June 2026 was not the end of the investigation. It was the beginning. The data from this object will be studied for decades. The questions it raises about how common ancient metal-poor star systems are in the Milky Way, about how frequently interstellar objects carrying prebiotic chemistry pass through solar systems like ours, about what it means that Earth sits in a galaxy that is, in some sense, raining ancient organic chemistry down onto it, those questions do not have answers yet. They have only the terrifying shape of what the answers might eventually look like. The Vera C. Rubin Observatory is expected to find many more such interstellar visitors when its full sky survey begins, and finding these objects earlier is the key goal of future missions, like the European Space Agency's Comet Interceptor. The European Space Agency is building a spacecraft, Comet Interceptor, whose entire purpose is to wait in space until an interstellar object is found incoming, and then intercept it before it gets close enough to the sun for its outer layers to melt away and contaminate the original chemistry. This mission exists because the scientific community knows that 3I Atlas was not the last visitor. It was not even unusual. It was just the third one we noticed. And with Rubin online and scanning the full sky at a depth and speed that no previous telescope could achieve, the rate at which we discover interstellar objects is about to increase dramatically. In February 2026, the Rubin Observatory launched real-time alerts for night sky monitoring, marking a historic milestone in astrophysics, with rapid monitoring of supernova, asteroids, and other astronomical events. This means Rubin is no longer just a telescope. It is now a real-time alarm system for the solar system. Every night, it scans the sky and generates alerts. Automated notifications that go out to the global astronomical community whenever something unusual is detected. Something moving at the wrong speed, something with the wrong brightness curve, something that should not be where it is. The universe is now being watched with a level of attention that it has never experienced before. And the universe, it seems, has things in it that are worth watching for. What is not being said loudly enough in mainstream coverage is this. Humanity has, in the span of roughly 18 months, gone from having 0 confirmed interstellar objects with detailed chemical profiles to having a fully analyzed specimen from a star system that predates our sun by 6 billion years. A specimen that carries organic chemistry, heavy isotopes, and molecular signatures that challenge our fundamental models of how the universe produces the building blocks of life. And the 2 telescopes responsible for this breakthrough, James Webb and Vera Rubin, are only beginning their investigations. They have years, possibly decades, of productive observational life ahead of them. The discoveries that have already emerged are not the peak. They are the very first slope of a mountain whose summit we cannot yet see. This is not chaos. This is revelation. And it is arriving faster than our institutions, our textbooks, or our collective imagination is prepared to handle. Consider the timeline. In July 2025, an interstellar object was spotted. Within weeks, Rubin's pre-discovery data was located, showing it had already tracked the object. Within months, every major telescope on Earth and in orbit had pivoted to study it. By October 2025, it survived a pass around the sun. By December 2025, Webb was reading its chemistry. By June 2026, a paper in Nature confirmed that this object formed over 10 billion years ago around a star that no longer exists, in a region of the galaxy that was metal-poor and primordial. and that it carries molecules associated with the chemical precursors to life at concentrations never before seen in any object studied within our solar system. That is 18 months from arrival to paradigm shift. 18 months from discovery to the realization that the solar system is not a closed system, that interstellar chemistry is not exotic and rare but potentially routine, and that the ingredients of what we call life may be distributed across the galaxy in quantities and forms we are only beginning to grasp. The world is not paying enough attention to what just happened. The press releases are clinical, the headlines are cautious, the papers are precise and methodical and deliberately understated in the way that scientific papers always are. But the data underneath the careful language is extraordinary. An object older than our sun, richer in prebiotic chemistry than anything we have ever found, passed through our solar system and was decoded in real time by the most powerful observational instruments in human history. And the two telescopes that did it, James Webb in orbit, Vera Rubin in the Chilean Andes, are now pointed at the rest of the sky, ready to find what comes next. Because something will come next. Comet 3I Atlas is the third confirmed interstellar visitor to our solar system. But with the Rubin Observatory now scanning the sky, many more may soon be found. The question is no longer whether more interstellar objects will enter our solar system. The question is what they will carry when they arrive. The question is whether the chemistry of 3I Atlas is typical for objects from ancient star systems. And if it is, what that tells us about the distribution of life's ingredients across billions of years of cosmic history. The question is whether some of those future visitors will be even more anomalous, even more chemically complex, even more ancient than this one. And the deeper, quieter question, the one that no press release will say out loud, is what it means that every time one of these objects arrives, it is carrying a chemical record from a star system we will never be able to visit, a message written in isotopes and organics that describes a universe far older and far more complex than the one we thought we lived in. We are not at the beginning of the end of cosmological mystery. We are at the end of the beginning. And the terrifying part is not what we have found. The terrifying part is the shape of what we have not yet found, the magnitude of what is still out there, still moving through the dark between the stars, still waiting to be caught by a telescope that is finally good enough to see it. James Webb is watching. Vera Rubin is watching. And somewhere, 10 billion light years of cosmic history are slowly, inevitably moving toward us. The real question is, are we ready for what they are going to find?